the sign of a vector components, adding vectors graphically. So copy and then paste. Now this is our vector C. This would be the vector D. This would represent So as of now, in the third chapter, we have discussed about vectors, its components, and how to represent a vector. Now in this video, we'll discuss about how to determine the sign of a vector components. And next, we'll discuss about adding vectors graphically. So how to add vectors graphically. So let's start with the first topic. So determining the sign of vector components. So let's take, this is a vector and we need to find the sign of the vector components. So its vector component in x and y direction will be ax and ay. So this is the vector component in the x direction and this is the vector component in the y direction that we studied earlier. So this is ay and this is ax. Now we need to determine the sign of these vector components. Now this angle is 90 degree. Now one thing you should know that this is what we call the tip of the vector and this is what we call the tail of a vector or tail of arrow. Now let's determine the sign of ax. So the rule is you have to start moving from the tail of the vector towards the right angle. So we'll start moving like this and this is positive x, this is positive y. Now if you are moving in the positive x direction, then ax will be positive, otherwise it will be negative. Now in this case you are moving along the positive x direction, so ax will be positive, or you could say ax will be greater than 0. Now for ay, you have to start moving from the right angle towards the tip of the vector. And if you're moving along the positive y direction, that means ay will be positive. So this is the right angle and this is the tip of vector. So we'll move like this. So ay in this case will also be positive because you are moving along the positive y direction. So this is also positive. Now there are 4 cases possible. Let's discuss all those cases one by one. So I've drawn all 4 cases and this is the a vector. This is also the a vector. Similarly a vector and a vector. Now let's try to determine the sign of a vector component in each of these 4 cases. So we'll start with the first case. Now this would be the x component. This is ax here and this would be the y component. So this is ay here. Now for this case, this is 90 degree. Now this is the tail. Now from tail to right angle you are moving in the positive x direction, so ax will be positive here. Ax is greater than 0. But ay, now we are moving in the negative y direction, so ay will be negative here. So this is positive and this will be negative. Now let's move to the next. This case we have already discussed above. This is ax. This is ay. So here ay and ax both are positive. So ax is also greater than 0. Ay is also greater than 0. This is the case we have just discussed in the previous slide. Now for this case, so this would be the ax and this would be the ay. Now this is 90 degree. Now from the tail to 90 degrees we are moving in the negative x direction. And here the ay will also be negative because from the right angle to the tail, to the tip of the arrow, we are moving in the negative y direction. So in this case, ax is also less than 0 and ay is also less than 0. So the final case is left. So pause the video and try to determine the sign of its component on your own. So I hope you tried. So this would be the component in x direction ax, and this would be its component in the y direction ay. Now this is 90 degree. Now here this ax will be negative because you are moving along the negative x direction. This is negative, and ay will be positive because you are moving along the positive y direction. So this would be the correct signs for its component. Now let's discuss one common mistake that students do generally while solving problems. So let's understand it with this question. Now here we are given that ax is negative 0.5 and ay is 1 meter. Then we need to find this angle theta and the magnitude of a vector. Okay, so earlier we studied that tangent theta is ay over ax, and from here this theta is tangent inverse ay over ax. This is what we studied. Now if we put the values here, so theta would be equals to tangent inverse ay we have 1 and ax we have negative 0.5. So this comes out to be as, if you use your calculator, you will get the answer as negative 63 degrees. So does this angle corresponds to the specified vector, a vector? So let's try to sketch this a vector first. Now here we see that ax is negative, so ax is less than 0, and ay is positive, so ay is greater than 0. So this vector would correspond to similar to this vector, a vector. So if we draw the a vector, so this is our coordinate system. This is positive x, positive y, and a vector will look something like that. This would be our a vector, and components of a vector, this is ax and this is ay. Now angle theta would be this angle theta because we measure the angle from the positive x direction in the anticlockwise direction. So this angle would be theta, and this angle theta would be in between 90 degrees to 180 degrees. So the correct answer for this angle theta should be equals to minus 63 degrees plus 180. So that comes out to be as 117 degrees. So this angle theta is 117 degrees. Now one question arises that why we are adding 180 degrees to it? Well, if you are familiar with the trigonometric angles, you might have studied that the value of tangent theta is equals to tangent theta plus 180 degrees, because the period for tangent theta is 180 degrees. That is, the tangent curves repeat itself for every interval of 180 degrees. So if you use the calculator, you will get this answer, because the calculator does not know which answer is appropriate for your situation. In our situation, the appropriate answer is 117 degrees. So you have to make your own decision that you have to, whether you have to add 180 degrees or not. So this is the common mistake that that people do. This is the correct answer. Now let's move to the vector addition. Now we can add vectors by using two methods. The first one is graphically, the next one by using its components. In this video, we'll discuss only the graphical method. The next method we'll discuss in the next video. So you moved 5 meter in the north direction, and then you moved 3 meter in the east direction. So this would like this. So let this vector be a vector and let this vector be b vector. Now you have to add vector a and b. Now one thing you should keep in mind before adding vectors, that to add vectors a and b, place the tail of vector b at the head of vector a, which we have already done it. Now here you can see that the tail of vector b is at the head of vector a. So they are placed in order. Let vector c represents the sum of vector a plus vector b. So vector c is obtained by joining the tail of vector a to the head of vector b. So let me draw it on the figure. So this is c vector. You are just joining the the tail, this is the tail, this is the tail of vector A to the head of vector B. So this is C vector, which we write vector A plus vector B. Now in our case, this C vector represents the net displacement. So this is how we add vectors graphically. Now the direction and the magnitude of this vector can be found by using scale and your protector. You just measure the length of this this blue vector that would represent the magnitude of vector. It would come something dash in meters. You can measure by using scale. Now this angle theta would be the direction for C vector. So this you can find by using your protector. Okay, now let's take one more example to have a better understanding that how to add vectors. In this case, you can take, there are three vectors. Vector, this is vector A, this is A vector. Next vector we have, let me draw it with a different color. This is vector B, and there is one more vector. Let me draw it with a different color. So this is vector C. This is C vector. Now you have to add all these vectors. Now to add all these vectors, we have to place these vector head to tail. Head to tail. What do you mean by head to tail? Here we have discussed that here we have placed this head of the vector A to the tail of vector B, and then we can add graphically. So here also we have to follow the same procedure. Now to place the vectors head to tail, we have to move vector from one place to another. But while moving, vectors cannot change its length and the direction, because vector is defined by its length and direction. So if these are unchanged, so does the vector. So let me take this vector. This is vector A. I'm just copying it and I'm just pasting it here. So this is our vector A. I'm just using the same pen. So this is vector A. Now next we have to take the vector B, because we are adding vector A plus vector B plus vector C. This is what we are doing. So the head of vector A to the tail of vector B. So this is the tail. So we have to take this vector. So I'm just copying it and paste. Now I have to match this the tail of this vector to the head of vector A. So this is the vector B. Now next we have this vector C. So same procedure. I'm just taking it here. So copy and then paste. Now this is our vector C. I've just placed the tail of vector C with the head of vector B. Now to find the resultant, or let this resultant be the vector D. Now to find this vector D, we have to join the tail of vector A, that is the tail of the first vector, to the head of the last vector, which in this case is C vector. So let's join. So this would represent vector A plus vector B plus vector C. So this is the way we add vectors graphically. Now let's discuss one more concept and then we'll end this video. So I've taken these two vectors. This is vector A and this one is vector B. And we need to add vector A plus vector B. This is our task. Now I've already placed the head of vector A with the tail of vector B. Now let C vector represents the sum of vector A plus vector B. Now to find the direction of vector C and the magnitude, we have to join the tail of vector A with the head of vector C. That is what we studied. So this vector will represent the C vector, and we can find its magnitude by just measuring this length and angle by using the protector, and we can measure this angle. Now suppose we need to add vector B plus vector A. We are just reversing the order. Then what would be the answer? Now so first we have to take this vector B, and then we have to join the head of vector B with the tail of vector A. So this is vector B, so I'm just moving this vector B from this place to the origin, but I'm not changing its magnitude, I'm not changing its direction. So this is the vector B, this would be the vector B. Now vector A, so I'm just taking this vector A from here and I'm joining at the head of vector B. So this would be the vector A. So this is vector B. I'm just making a dotted line so you don't have any confusion. Now, how to add this vector B and vector C? So join the tail of the first vector with the head of the final vector. So the C vector would represent the addition of vector B plus vector A. So from here we conclude that the sum of a vector is independent of the order in which we are adding. That is, whether if we are adding A plus B or B plus A, you will get the same result. This is what we have proved here. And because this figure looks like parallelogram, we call this method to be as parallelogram method. So this is all with this video, and in the next video I will discuss how to subtract vector and how to add vector by using its components.